Hello students, today this is our vectors. So some problems related with vectors. Find the value of lambda so that the vector A and vector B be perpendicular. So vector A and vector B is perpendicular where to each other, where vector A is given 2I plus lambda j plus k. I, j, k are unit vectors, and B vector is I plus 2j plus 3k. The two vectors are given. We have to find out that two vectors are perpendicular, and from this we have to find out the value of the lambda. So how we can find out? Here we know that from vectors scalar dot that A vector dot B vector equal to mod of A vector multiply mod of B vector multiply cos theta. So where if they are perpendicular to each other, so theta, the angle between the two vectors be equal to pi by 2. So cos theta is equal to 0. Now this form will be changed to A vector dot B vector equal to 0. So A vector dot B vector can be found out in this way, that I vector multiply I vector plus lambda vector multiply minus 2 means j vector multiply j vector and k vector multiply k vector. In vectors multiply in scalar dot, the similar vectors can multiply, other multiplications are become 0. So we just take similar unit vectors can multiply, and we will take the value of similar vectors multiplication. This will be 2 multiply 1 plus lambda minus 2, which will be minus 2 lambda, and 1 multiply 3. So we will have, and this is equal to 0. This is equal to 0. So if we calculate this, it will be 5 minus 2 lambda, which is equal to 0. So from this lambda we can find out 5 by 2. So this is the required value of lambda 5 by 2, which makes A and B vector perpendicular to each other. Now we are going to another problem. Find the angle between the vectors A and B, where A vector is given, A vector is 5i plus 3j minus 4k, and B vector is given 6i plus 8j minus k. So how you can find the angle? We will use the same formula, A vector dot B vector equal to mod of A vector multiply mod of B vector multiply cos theta. So from this we can find out cos theta will be A vector dot B vector mod of A vector mod of B vector. So we will use the here. So cos theta, A vector is given 5i plus 3j minus 4k and B vector is given 6i plus 8j minus k. So we have to find out cos theta, which will be equal to A vector dot B vector mod of A vector mod of B vector. So A vector dot B vector will be again similar vectors, the unit vectors can multiply, and other vectors will be 0 actually. So similar vectors get multiplied. So I multiply I, j multiply j, plus k multiply k. So this will be 5 multiply 6 plus 3 multiply 8 plus minus 4 multiply minus 4 multiply minus 1, and in modulus value will be root over x square plus y square plus z square. This will be 5 square plus 3 square plus minus 4 whole square, and here it would be 6 square plus 8 square plus minus 1 whole square. So if we solve this, we will get 30, 6 by 30, 8 3 24, minus minus plus 4, and here it will we will get 5 by 25 plus 3 3 9 plus 4 4 16 multiply 6 6 36 plus 8 8 64 plus 1. So we will get 30 24 4 50 58, and here we will get 25 9 34 25 plus 9 34 plus 60 50 to 50, and here we will get 36 plus 64 100 101 101 we will get. So this will be 58 by this will be 5 root 2, and here we will get 101. This will be 5i plus 3k minus 4k. Here it is given 6i plus 8j minus k. One, it remains same to 101. So we will get 58 by 5 multiply 202. So if we multiply this with 202, we will get with root over 202, we get 58 root over 202 by 5 multiply 202. So this will be 29, this will be 101, so this will be 29 root over 202 by 505. So we can find out theta from this. From this theta can be found out. Theta will be cos inverse 29 root over 202 by 505. So now another problem we will discuss. Here given three vectors, A vector, B vector and C vector, which value are given. A vector is 3I minus 2j plus k, B vector is I minus 3j plus 5k, and C is 2I plus j minus 4k. So three vectors form a right angle. We have to show how we can show that three vectors form a right angle. So we take that these are the position vectors of these three vectors. This is the position vector of the A vector, this is the position vector of the B vector, and this is the position vector of C vector. Now we will try to find out the length made by these three vectors. We take that these vectors lies on the corner points of the, so if this is the Cartesian plan, this is O, we will take this is A vector, this is B vector, in this way we will take the three vectors, and this is C vector. So to find out the length we use, we know if two vectors, the length between two position vectors will be, if we denote this, the length in this way, then it will be root over x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square, where x1, x2, x1, y1, z1 are these 3 points related with I, j, k, and x2, y2, z2 are the 3 points related to the other vector, position vector with I, j, k. So we can find out this in this way. We will take, if we give names A, B, C of the triangle made by these three vectors, then we will take AB. AB is the length, so we will take AB line segment whole square is equal to, we will not use the square root, we will just use the inner form under square root. This will be, I am writing here again, A vector is given 3I minus 2j plus k, B vector I minus 3j plus 5k, and C vector is 2I plus j minus 4k. So the line segment made by the two vectors AB, which is AB square, will be 3 minus 1 whole square plus minus 2 plus minus 3 whole square plus 1 minus 5 whole square. This is 5, 1 minus 5 whole square. So this will be 2 square plus 5 whole square, minus will not be under the square form, and this will be 4 is whole square. This will be 4 plus 25 plus 16. So this will be 45 square unit. Or you can find out the length but we have to use the Pythagoras form, which is for the right diagonal, which is height square plus base square is equal to hypotenuse square. So we are not going to find out the length, just we are deducing height square or length square or hypotenuse square. Now by BC length, line segment length will be 1 minus 2 whole square plus minus 3 minus 1 whole square. Sorry, this will be 3 minus 1 whole square minus 2 minus plus 3. This will be 1 minus 5. So here it will be 1 whole square. This will be 1. This will be 21. This will be 21 just. So it will be 1 minus 2 whole square minus 3 minus 1 minus 4 whole square. Here will be 5 minus 4. 5 minus 4 whole square. So this will be 1 whole square plus 4 whole square plus 1 whole square. So this will be 4 for the 16, 17, 18. 18 square unit. Unit square. Now we have AC whole square. AC will be 3 minus 2 whole square plus minus 2 minus 1 whole square plus 1 plus 4 whole square. So this will be 1 whole square plus minus 2 minus 1. It will be 3 whole square plus this will be 1 plus 4, 5 whole square. So this will be 9 and 25. 9 plus 25, 34 and 1. 9 plus 25, 34 plus 1, 35 square unit. This is 21. This is 18. 4, 1, 4, 1, 5. So we have 21. Sum of two must be equal to another. So these are the smaller units. They must sum to and equal to this. I'm checking just that there is any error. We have to show, that's why. 3 minus 1, 2 whole square minus 2 plus 3 plus 3. So 1 whole square. 1 minus 5. This is 1 minus 5, 4, 4 whole square. 4 plus 1 plus 6, this is 21. Now BC 1 minus 2, 1 whole square minus 3 plus 1. plus 1 minus 1 is 3 minus 1 minus 4 whole square, and 5 minus plus 4, 5 minus 4, so 9 whole square. So this will be 9 square plus 4 square. 9 9 is 81. 5 plus 4, 9 will be 81 plus 16, 17. 81, 17, 98. The last one, 3 minus 2, 1 whole square, minus 2, minus 1, 3 whole square, and 1 minus 4 plus 5. So this will be 55, 21. Vectors are taken again, and taking again the vectors. Again vectors are, a vector is given 3i minus 2j plus k, the vector I minus 3j plus 5k, C vector I plus j minus 4k. So I have taken, this is OP or OA vector. This is I have taken OB vector, and this is I have taken OC vector. And the diagram I have drawn in Cartesian plan in this way. The x-axis, this is y-axis, this is O. I have taken 3 points in this way. This is A, this is B, and this is C. So OA vector is given by A vector, and OB is given B vector, and OC is given by C vector. So to find out the length AB, BC and AC, so AB whole square will be 3 minus 1 whole square plus minus 2 plus 3 whole square plus 1 minus 5 whole square. So it will be 2 whole square plus 1 whole square plus 4 whole square. 4 plus 1 plus 16, so it will be 25, 1. BC square 1 minus 2 whole square plus minus 3 minus 1 whole square plus 5 plus 4 whole whole square, 1 whole square plus 4 whole square plus 9 square, 1 plus 16 plus 81 is equal to 98. AC vector is 3 minus 2 whole square minus 2 whole square plus minus 2 minus 1 whole square plus 1 plus 4 whole square. This will be 1 square plus 9 3 whole square plus 5 whole square. This will be 1 plus 9 plus 25. And that 5. So you can look this. Here you cannot find out that the bigger unit is sum of the other two units. Some misprinting in my book. Some misprinting I am looking. I have done twice, but some misprinting I am hoping. So it is the procedure. If three vectors are given, if we have to show they form right angle, so we have to do this procedure, and we have to find out that the bigger is equal to, means hypotenuse square is equal to base square plus height square or not. If this happens, then we can say that it is a right angle triangle, because you know by Pythagorean theorem that base square plus height square is equal to hypotenuse square. But here we cannot prove this. Thanks for watching. Have a good day.